Hello guys, welcome to today's class where we'll be taking another example on how we can actually apply a combination method to solving a binomial theorem question. But then in this case, this question has some peculiarities in the sense that we'll be looking at the negative index. That is, our powers in this case will be a negative power, and then how we can actually apply the knowledge of combination to solving with a negative power, even though we are not supposed to be using a negative power in combination. But then we'll be showing how we can apply that mathematically. So just follow me through this. Now we have this, we have a over 3 plus 1, all raised to power minus 3. As our example 4, we have a over 3 plus 1, all raised to power minus 3. And then we want to use our knowledge of combination, because that is actually the only way we can actually approach this question. We cannot use Pascal's triangle because we don't have a positive power. Our power is the negative integer. So the only method here we can use is the combination method. So in order to do that, we need to derive our coefficients using our knowledge of combination. So I say my total power, which is minus 3, combination 0. I take the first one. In this case, we're given number of terms to take. In this case, we're not told number of terms. So we can take as many terms as we want. But for proprietary sake, we are advised to take at least 3 terms. So you can take 3 terms. You can take more than 3 if you want to. But here we'll be taking 3 terms. So we have minus 3 combination 0. The first term is a over 3, which will be taking the total power of minus 3, and then 1, which will be taking power of 0. Moving on, go to the next term, we have minus 3 combination 1. We have a over 3. So you subtract 1 from the previous power, which is minus 3. Move 1 from minus 3, that will be minus 3 minus 1, giving us minus 4. So that one that we subtracted from there, we'll now add it to this one. So adding it to this one now, we have 1 raised to power 1. So the next term, we have minus 3 combination 2, where we have a over 3 raised to power. Subtracting 1 again from minus 4, we have minus 5. And then adding that 1 to the second value, I'll have 1 raised to power 2 plus ellipsis. That is to show that there are more terms that we can actually also still simplify or account for. So we are just stopping here for statistics sake. In this case now, I can break this down. My knowledge of combination, that was, I will have minus 3 factorial over minus 3 minus 0 factorial, 0 factorial. Where I can say this will remain a over 3 raised to power minus 3. I know 1 raised to power 0 remains 1, so I don't need to write that out. I know this is minus 3 factorial again over minus 3 minus 1 factorial, 1 factorial. I know this will give me a over 3 raised to power minus 4. I know 1 raised to power 1 is still 1. So I don't need to put that. I know this is minus 3 factorial over minus 3 minus 2 factorial, 2 factorial. This is a over 3 all raised to power minus 5 plus ellipsis. That is the other terms that we're not accounting for now. So moving forward, I can say from here that this gives me a value. Simplifying this, I will have minus 3 factorial over minus 3 factorial times 1, which is 0 factorial. So I know my knowledge of indices, a over 3 all raised to power minus 3 simply means 3 over a all raised to power 3. Plus the same thing here, I have minus 3 factorial. So to break this down, my knowledge of combination, I can easily say this is minus 3 times minus 3 minus 1 factorial all over minus 3 minus 1 factorial times 1. I know for my indices, I can use for my negative index law in indices, I know this becomes 3 over a all raised to power 4. Plus next one, I have minus 3 times minus 3 minus 1 minus 3 minus 2 factorial all over minus 3 minus 2 factorial times 2. Here, I'll be having 3 over a all raised to power 5. Moving on, I know my minus 3 factorial can cancel out. I'll be left with just 3 over a all cubed. Plus this one cancelling this out, I'll be left with minus 3 into bracket 3 over a raised to power 4. Plus the next one, this cancelling this out, I'll be left with minus 3 times minus 3 minus 1, which is minus 4, all over 2 multiplied by 3 over a raised to power 5. So breaking this down, breaking this down, all I need to do is what? Is simplify the following. I know 3 raised power 3 is 27 over a raised power 3 is a cubed. I know. Then I have plus and minus, will give me minus. This is minus 3 into bracket 3 raised power 4 is 81 over a raised power 4 plus minus 3 and minus 4, that's 12. 12 over 2 into bracket 3 raised power 5 is 243 over a raised to power 5. Let's not forget our ellipses to show that there are more terms that we could actually have simplified. Equals to 27 over a cubed minus, it's 1 times 3 here gives me 243 over a raised power 4 plus, then we have 12 times 243, which is giving us 2,916 divided by 2, giving us a value of 1,458. 1,458 divided by a raised to power 5. So I can say this is my answer, or I represent it in the term 27 a raised to power minus 3 minus 243 a raised to power minus 4 from my knowledge of indices, that is my negative index law, plus 1,458 a raised to power minus 5. So this becomes my answer. See you in the next class. We'll be looking at another example, but then we'll be treating the idea of combination, using it to solve fractional indexes, that is fractional indices rather. So we're using to solve fractional indices of binomial expansion. See you next class.